The ocean covers most of the surface of our planet, and its waters seem familiar and constant. But once a person begins to think about its properties, a simple yet fundamental question arises. Why is the ocean salty? After all, rainwater and the water of most rivers are fresh, so it would seem logical that the oceans, which collect all these flows, should also be fresh. Yet, in reality, each liter of seawater contains about 35 grams of dissolved salts. This means that roughly 3.5% of all ocean water is made up of salt, and it is precisely this that gives it its characteristic taste. To understand how this came to be, we need to look at the long history of interaction between water, the atmosphere, and the Earth's crust. It all begins with rain. At first glance, rainwater should be completely pure, but in reality, this is not the case. Before a raindrop falls to the ground, it passes through the atmosphere and absorbs a small amount of carbon dioxide. As a result, a weak carbonic acid is formed, making rainwater slightly acidic. Such water slowly breaks down rocks, entering into chemical reactions with minerals. This process is called weathering. Over time, rainwater washes out from rocks and soil many different substances: calcium, potassium, magnesium, sodium, and other elements, as well as anions such as chloride, sulfates, and carbonates. But the most important thing is that water does not remain in one place. With the rain, these substances flow into streams, the streams merge into rivers, and the rivers carry the dissolved minerals further into the seas and oceans. Each river by itself is fresh because the concentration of dissolved substances in it is relatively small. But if you imagine millions of rivers and streams, which for billions of years have carried dissolved minerals into the oceans, it becomes clear that the result of this continuous process must be the accumulation of salts. And indeed, the ocean is a closed system. It has no outlet like a river that flows onward and carries substances away. Water from the ocean can evaporate under the sun, but only pure water molecules rise into the atmosphere during evaporation. The salts and minerals remain behind. As a result, for millions of years, the oceans have been constantly replenished with salts, but almost never losing them. The seafloor itself also plays an important role. On its surface, there are hydrothermal vents, the so-called black smokers, as well as volcanoes releasing minerals and gases directly into the water. In the depths of the ocean, chemical reactions occur between water and the rocks of Earth's crust. All these processes enrich the water with even more dissolved substances. Of particular importance is chlorine, which, when combined with sodium, forms sodium chloride, the common table salt we know. It makes up the majority of sea salt, which is why the taste of seawater is so similar to the salt we use in everyday life. One might wonder, if rivers carry many different elements into the ocean, then why is seawater mostly salty, rather than, for example, bitter or sour? The answer lies in the behavior of different ions. Calcium and carbonates often precipitate out, forming limestone and other rocks. Some substances are absorbed by living organisms. Corals, mollusks, and plankton use calcium to build their shells and skeletons. In this way, many minerals are removed from the water naturally. Sodium and chlorine, however, rarely precipitate and are poorly absorbed by organisms. That is why they accumulate in the ocean in the largest amounts, and their concentration is what defines the saltiness of seawater. Interestingly, the salinity of Earth's oceans has remained relatively stable. Even though rivers continue to bring in new salts and weathering processes never stop, opposing processes are also constantly at work. Some salts settle to the bottom as sediments, others become part of mineral cycles, and some are captured by living creatures. As a result, the ocean on average maintains a balance, and its salinity has remained nearly constant for millions of years. From a scientific point of view, oceanic salt is evidence of the long-term interaction between water and Earth's solid shell. One could say that each drop of seawater contains the history of rains that once fell on mountains, the history of rivers that carved valleys for ages, and the history of volcanoes releasing minerals from the planet's depths. All these processes come together into a single picture, and the result of this colossal work of nature is something we taste every time we accidentally swallow a little seawater. The ocean is not salty because someone added salt to it, but because over billions of years, Earth itself has gradually dissolved its rocky treasures into the water. This is what made the oceans what they are to